Hi everyone, good morning. So today I'm going to talk about something so-called quadratic function. Now let's take a look on an example. Let's suppose we have a square and the length of the side of the square equal to, for example, s. This is also s. I guess some of you already know if you want to get the area of a square will be equal to the square of the sides here. So basically this is just, the side times side, or we can just write it as s to the power of 2, s squared. Now, when you want to write down these letters, actually we can also use some other letters. So instead of just writing all the time like the area and then s like this, well, sometimes we can also use some popular or famous notation, for example x and then y. Yeah. Now if you look at this area, we can say that the area of a square depends on the side, right? Now this formula can be written as, for example, now if I want to write the area using notation, for example, y, and then if you write this length of the side to be x, so you can write down that y equal to x squared. So you see, basically, this is just the same thing. Yeah, the area equals to s squared, and now I'm using this notations, yeah, x and y, instead of writing area and also the sides here, I'm writing like this, y equal to x squared. So now when you wanna see the graph of this y equal to x squared or the area equal to s squared, you can plot them on the Cartesian diagram. Yeah, so basically it's just a diagram that has two axis. Yeah, so let me now put like this. The horizontal axis, we call it the x-axis, and then the vertical axis, we call it the y-axis. Now, when you want to draw a graph of this, for example, relation, yeah, you can, make like a table. So, for example, this is the x value and this is the y value, yeah, and you can put the numbers now. For example, when the value of x equals to 0, that gives you 0 square or just 0. And then when the value of x equal to 1, that will give you 1 square, or in this case, it's just 1. Now, when the value of x equal to 2, you will see that now 2 square, it's just 4. And then when the x value equals to 3, what you will see is now the y value becomes 3 square or 9. And then when the x value equal to 4, the y value will become 4 square or 16. So from these values, now you can try to put them in the Cartesian plane. So for example, this is the origin or the location of that, it's 0, 0. Yeah. And then we can have now this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, okay, so we need a bit longer, yeah, 15, and then 16, yeah, so I'll just go up to 16 now for the y value, and then the x value will be 1, and then 2, 3, and 4. Now when you try to connect the points, yeah, so for example this 0, 0, normally we will write it using the bracket, so we will write it as a pair like this one, 0, 0, yeah, so this is just the first value here is for the x, and then the second one is for the y, so 0, 0 is located here, right? And then this number now, which is 1 and 1 also, is located somewhere here, okay? There. And then when you go further, for example, this one now, when the x value equal to 2 but the y value equal to 4, so it's written like this, yeah, bracket, and then 2, 4, close bracket. So it is somewhere there, right? And then when the x is 3, give you the y value equal to 9. So it is somewhere here. Now, when the x value equal to 4, the y value equal to 16. So it's written like this bracket, and then 4, 16. Right. So it's somewhere here. Yeah. So basically the y value is 16, and then the x value equal to 4. Now when you try to connect these points, basically what you want to do is to connect them using a curve, bending curve, not using the lines. Yeah. So just, yeah, I'll try to make it as good as possible. Something like that. Yeah. Now this is actually quite interesting, because when you have this quadratic relation, that doesn't give you a straight line anymore. So this is not the linear relation anymore between these two numbers, these two values, between x and y values. Yeah. In fact, if you try to think about like negative value of x now, yeah. So this is, now we are doing more general for x, yeah. It's not just a square. So for example, now if you have a negative value for the x, for example, x now equal to -1. So when you put into this relation y equal to x squared, yeah, that gives you y equal to, so -1 squared give you 1, right? And then when the x value is -2, it gives you -2 squared, which is 4. Yeah, and then -3 squared, it is 9. And then -4 squared, it is 16. So now look at this. When you want to see where they are located, for example, this one, where the x value is -1 and the y value is 1. So you go to the negative x, which is the left side of 0, yeah, and then that is the point where x is -1 and then y is 1. So this one will give you this point, yeah, where the x is -2 somewhere here, and then the y is 4. Now this one, yeah, -3,9 will be located somewhere here, yeah, and then this one -4,16 will be somewhere here, yeah. So this is -4. Yeah, I think the best way is to use ruler, right? Now you will do the same thing again. Basically, you will need to connect these points using bending curve like this one, and you will get the other side of this typical curve that we call it a parabolic. Yeah. So when you have a quadratic relation like this will give you a parabolic curve. Yeah. Now, when I say relation, what happens is actually in mathematics, when we talk about relation, you can have something so-called equation, or you can have something so-called function. And essentially they are different. Yeah. Now, for example, if you talk about this one, y equal to x squared, this mathematical relation is called function. So now let me explain what function is actually. Okay, so function is a relation for which for each x value on an order pair, there is a unique value. There's a unique y value of the order pair. Namely x comma y. So I guess the best way to understand this one, now let's suppose you have another relation, but this time I give you something like this, yeah? For example, x squared plus y squared equal to a value, a number, for example, equal to 25, yeah? So for those of you who already know about this equation, I guess you know what I will gonna do. So now let's go to the Desmos website, yeah? Right. So what I'm going to plot you now, the first one I'm going to plot y equal to x squared, which give us the curve that we had before, yeah? This is called the parabolic curve, and see if you zoom out this curve, this is what you will see. Yeah, it will give you a nice and beautiful parabolic curve, right? And it's symmetric. So we'll talk about this property later in the next session. Now, when I have now the equation x squared and then plus y squared equal to 25. Now, when you look at the second graph, which is the blue curve, that you will see is a circle. So this is an equation of a circle, the equation of circle, yeah? Okay. Now the difference between these two, the first one, yeah, the red curve, it is a function. And then the second one, it is an equation and it's not a function. So how do we test if we have relation and that's a function? Actually, the best answer for it, we can do something so-called vertical line test. So basically what it does is like this. When you try to, you know, cut the graph with a vertical line, yeah? So for example, now I will try to plot vertical line like this, and you see if the line only cuts your graph at one point somewhere, yeah. Now if you plot another vertical line here, for example, it also cut one point here, yeah. So basically all of those vertical line will only cut at one point in your graph, yeah. So basically that tells you when there is only you know, one intersection point between this vertical line in your and your graph, that shows this is a function. Okay, so that's the simplest way to see if you have a function or not. Now, for example, if I look at the second one, yeah, which is the circle, and then I try to do the same thing now, I try to you know, plot the vertical line, yeah. And now if you look at this vertical line, it cuts your graph, that circle, at 2 points. Yeah, at 2 points. That means for this x value, yeah, this point of x, this x value doesn't give you a unique value of y. That doesn't give you a single value of y. So you see now that this x value gives you 2 points of y here and there, which the first one corresponds to this number here, and then the second one corresponds to the negative value of it. So when you do the vertical line like this, and then it cuts your graph at 2 points, yeah, somewhere and somewhere, that proof, that shows that this is not a function. All right? So this is not a function. So I guess this is the basic idea that you need to know whether you want to see if we have a function or not. Now let me give you another example. Yes, for example, if I have just the straight line equation like this one, y equals to 2x minus 10. Is this also a function? Well, in this example, of course, we can say when you do the vertical line, yeah, when you now try to plot the vertical line, and then you see everywhere, the vertical line only cuts at 1 point, and that also shows this is also function. This is function, okay? The y equal to 2x minus 10. Let me give you one more. For example, y equal to x cubed. There. So now you see the purple graph here. Again, when you want to see whether this is a function or not, the best way is just to do a vertical line test and then see whether the line will cut your graph at 1 point or not. So in this case, if it only cuts at 1 point here, for example, this vertical line, it cuts only at 1 point here, it shows that this is a function, okay? Yeah. So this is something that you need to know first, yeah, to determine whether the mathematical relation that you have is a function or not, okay? Because you can have either equation, like the equation of circle, yeah, or you can have now something so-called function. I think the next discussion that I want to discuss with you, I will talk more detail now. I will talk about the quadratic function more detail. Okay, so the general form of it will be something like this: y equal to x squared, yeah, but you can also have some additional terms also. So we'll talk about it later. But now I think my take-home message for you will be this one. Function is a relation for which, for each x value on the an ordered pair, there is a unique y value of the ordered pair, namely x and y. Now this one is not function, you know the reason there for it. All right, so I guess that's for today, and I'll see you next time. Thank you.